Welcome, Algebra 2. This is our quiz review for 5152. I'm Mr. Hibble, and today we're just going to go through some problems in preparation for our quiz coming up. One thing you're definitely going to need to know is how to factor. Factoring method determines on which process you use. So when I see this first problem, first thing I notice for it is this first one has 4 terms, right? 1, 2, 3, 4 different terms. Well, whenever there's 4 terms, our factoring method is grouping. So we create our groups, make sure there's a plus sign in the middle, and then you want to divide out whatever the GCF is in both those groups. Remember, if you go into Desmos, type in GCF with whatever the values are, it'll tell you what number we should be dividing by. When I look at these this first group here, I have p cubed and p squared. Well, if I have a group of 3 and a group of 2, you need to take the same amount from both. I believe that means you can take 2 out of each. So we're going to divide by 1p squared. You could just call that p squared. So when you go through this, then, you want to start dividing it out. 8 divided by 1 is 8. P cubed divided by p squared. You're dividing variables, so subtract your exponents. 1p squared over 1p squared, something divided by itself is 1. The p squareds cancel, just giving us 8p plus 1 on the inside. Divide the second one by whatever the GCF is that Desmos tells you. And remember, if you do this correctly, your parentheses should match. When your parentheses do match, you can factor that out one more time. 8p plus 1, where it's multiplying with 2 things. 8p plus 1 was multiplying with 1p squared, and it was multiplying with 6. We have now shown that, and we are done with our factoring on number 1. Number 2, same idea, factor that one. Find what goes into the first set and into the second set. Divide out your GCF. I believe 3n squared for this first one. Dividing it out, I believe that'd be 4n plus 1. Again, something divided by itself gives you 1. When you divide variables, again, make sure you are subtracting the exponents. Divide out for the second one as well. Again, your parentheses should match. In this case, they do. When they match, that parenthesis moves all the way to the front, creating one parenthesis. And the other 2 now become this second set of parentheses. Okay. 3 and 4, look at how many terms they have. On number 3, I notice there's only 2 terms. When there's 2 terms, you want to use our difference of squares. I almost said squirrels. Difference of squares formula, where you find whatever your term is, find what multiplies with itself to give you that. So 25 is the same thing as 5 squared. X squared is the same thing as x raised to the second, and 81 is the same thing as 9 to the second. Well, once you have it written like that, whatever's on the inside goes into your 2 parentheses, where the first set you can have adding, the second set you can have subtracting. The order of those parentheses doesn't matter. You could have the minus first, then the plus, but there is your factored form. Fourth one then, factor that. There's 3 terms in this one, so it's not difference of squares. It's not groups. We need to use our ABC method. Well, when you have ABC method, the first thing you're trying to do is find 2 things that multiply to your A times C. Our A and C is 4 and 3, which gives us 12. And we want to find 2 things that add to our B value, which is 7. You could break down your A and C value of 12 to find what multiplies into it. And then once you have that list, you can check through that list to see which of these would combine to 7. We find 3 and 4 together. Well, when you're doing that, what we can do then is we are allowed to do what's called splitting the middle, where you take the middle term and you make it 2 different terms. The 2 values we just found is what we are going to change the 7 into. So the 7 is now 2 parts, it is 3y and 4y. If you add those together, it does give us 7y. So this step is allowed. We do have equivalent lines. From there, notice we now have 4 terms. Once you have 4 terms, we know what that process is. Create your groups. Once you have your groups, divide out your GCF. Whatever you divide by goes in front. Whatever is left inside is in your parentheses. So going through that then, once your parentheses match, factor that out to the front. Whatever's left in front of them goes into the second set of parentheses. Now we have our factored form. From here, we could also take this into solving algebraically. The process for that is the same. You still want to go through your factoring method. So for number 5, that would be our ABC, finding what multiplies to 12 times 9. 12 times 9 is 108. And we need to find what adds to negative 21. So you could take 108, you could go into Desmos, find what goes into it. 1 and 108, 2 and 54. 3 would go in 36 times. 4 would go in as well. That would go in 29 times. 5 does not. 6 would go in. That would go in 18 times. And as you start to make this list, we want to know what can we make combined to 21. So those don't look like they'd work. 6 and 18 wouldn't work. And then we continue to check. Okay, I believe the last one then is 9 and 12. And that does work. 9 times 12 does give us 108. We knew that originally. And they do combine to 21, but notice we need it to combine to negative 21. Well, if you multiply to a positive, your signs have to be the same, so maybe we make both these negative. And now that would combine to negative 21. Split the middle, take your terms, separate the middle term now with the 2 values we just found. Make sure there is a plus sign in between. And start to factor from there. Divide out your GCF. Once you take out the GCF, see what's left on the inside. Do that for both sets. Notice since the 12 was negative, I am going to divide out the negative with it. If the first thing in your parentheses is negative, you should take it out. When you do that, that now gives me my factored form. But we're not just factoring anymore, we're solving. So in order to solve this, you separate it. Set both parentheses equal to 0 separately and solve your equations. First one would give you x equals 3/4 when you solve it all the way. Second one would give you x equals 1 when you solve it all the way, canceling out whatever operations were happening. That's how we can go through the solving process. Same idea for 6, 7, and 8. I'm just going to start to go through that process real quick. On number 6, this is difference of squares. What squared gives you x to the 4th, though? Well, that would be x squared squared again. Okay, and then once you have that, create your difference of squares equation. Once it's in its factored form, you can solve it. Start to move everything to the other side. Notice I have x squared in this case. In order to solve an x squared equation, you have to square root both sides to get rid of the squared part. When you take a square root on both sides, remember you always get plus or minus. The square root of 9 is 3. The square root of a negative does give us I. We have 2 answers there, positive 3i and negative 3i. Same idea with this other equation. Move your values over, take your square root. Don't forget your plus or minus. Square root of 9 is still 3. This was a positive square root, so it is so there is no I on this one. 7 and 8, same ideas. Go through your factoring. These are 4 terms. Go straight to your groups. Divide out your GCFs. Again, if the first value in your parentheses is negative, go ahead and divide it out as well. Once your parentheses match, create your 2 equations, or your 2 factors, I should say. And then you can create your 2 equations where they are both equal to 0. And you can go through your solving process. X equals 7. And get rid of the square by square rooting, where x is now equal to plus or minus square root of 3 over 2. Okay? Same idea for number 8. I'm just going to speed through that one real quick. Follow along. Check your answer after this one if you need. But again, it is just that same idea. Separate it like before and solve. If you were to solve this one, you'd get positive 3 over 2, which we see that now. If you were to solve this other one, again, that 1 in front of the x squared is not necessarily needed. So x squared would equal negative 2. Take your square root. X equals plus or minus the square root of 2. But since it was negative, don't forget the I. That is our solving process. Now let's go ahead. Let's look at the rest of what we need to know with 9, 10, 11, and 12. So looking at number 9, this one says, how many solutions does the polynomial equation have? Well, what you're going to want to do for that is just go ahead and graph it. So start by typing that into Desmos. But remember, when you type that in, when we're finding solutions, we want to have 2 separate equations. Okay, we're not just going to type in the original thing as is. We're going to type it in as 2 separate equations where y is equal to the left side and y is equal to the right side. You separate it at the equal sign. And once you do that, then type it into Desmos, see what it looks like. I'm going to do that real quick as well. And we will compare graphs. So 3x to the 4th minus 2x to the 3rd plus 6x squared minus 8, and that's equal to y equals 10. So when you graph them, you want to find where they cross, remember. And what I'm seeing on my graph when I type this into Desmos is one function that looks something like this and another function that's just coming straight across. Find where your 2 lines intersect. Desmos is nice. You can click on those different coordinates. Notice we were originally solving for x in our equation, so I only care about the x values in these coordinates. I believe you get x equals 1.405, and you get x equals negative 1.193 or 192, depending on how you want to round it. But we're wondering how many solutions, not what are the solutions. I see it's crossing twice, so I would say there are 2 solutions to that problem. Number 10, given the factored form, what are the solutions? Well, if you're already have the factored form, it's pretty simple to solve it then, right? We've already done some problems where we were solving where once it was factored, you'd set them all equal to 0 and you solved. So now you just have to solve each of those, seeing what we end up getting. X equals 5/3. X equals 4. And x equals negative 4. That's an 8 there. That's a sloppy 8, but you guys see it there. The volume of the box as shown is 216 cubic feet. Determine the dimensions of the figures. Solved by graphing is our strategy here. Well, we have 3 dimensions here. And in order to find volume, you multiply those 3 dimensions. The length, the width, and the height all get multiplied. So let's just show that multiplication first. Something like this. We also know the volume, right? They say the volume is this amount. If you know what something is equal to, you can replace it. So I'm also going to replace the V with 216. Well, again, this is an equation that we can solve by graphing. Create two equations. Set them both equal to y and see where they cross in Desmos. If we were to do that in this case, let's go ahead. Let's find our solution right now. Again, just typing it into Desmos and seeing where they cross. Notice one of your values is 216. You're probably going to have to zoom out to find that value just because it is a larger number. So make sure you do zoom out until you see both lines, not just one of them. And what you would end up seeing is something similar to what we had before, but now it's probably going to look something like this, where it's kind of a straight up line with a line sideways. And if you click on it, it says they cross at 4216. Again, we only care about the x value at that spot in which they intersect. But what they said is determine the dimensions. They didn't just tell us to solve for x. They want the actual dimensions. Well, remember, the length is x plus 2. But now I know what x is equal to, so I can plug in that value. In this case, I know the length is 6. We can plug in for the width. You can replace x with the value. Your width is 4. You can plug in for the height as well. Get rid of the x value and find your amount for the height, where you'd get a height of 9. We know that the dimensions of this box are 6 by 4 by 9. That would be in terms of feet, it looks like. A 6 by 4 by 9 box. Number 12, same idea. You're given some equation here. It's just telling you what's kind of happening. It says h is the height in feet and t is the time in seconds. And we want to know when Scott's kick hit the net behind the goalpost at a height of 3. Well, if they tell you what the height is, you know what something's equal to, you can replace it. So our equation now, we replace h and get something like this instead. So from there, again, just solve it in Desmos, see where they cross, create your two equations, type it in, see where they intersect each other. And if you were to do that, let me type it in real quick, see what I get. Negative 16 t squared. If you type in y equals, Desmos is okay with t. It does understand that. However, if you do not type it in, though, Desmos will not understand what t is. Okay, so be careful. To me, it looks like there are two solutions in this case. And when you click on them, you find different x values. An x value of 1.29, an x value of negative 0.4, or sorry, these are technically t values, not x. Remember, t is in time or in terms of seconds though, so what I'm noticing is this left one is a negative seconds, so that would not work. So we know that our answer then would be this one. It takes about 1.29 seconds for the ball to hit the post. That is our review. Make sure you're ready to go for our quiz. Good luck.